Hello everyone. In this video, I am going to discuss the topic of material science. In this topic, the main theme is free electron concept. Before discuss this free electron, let us brief out the entire module. Free electron can be developed in three main stages. So one is classical free electron theory, second quantum free electron theory, third one is semiconductor theory. Now let us discuss one by one. So the first one is classical free electron theory. So the first it was developed by Drude and Lorentz in 1900, and they have assumed that these free electrons are randomly moving, hence which obeys the gas law. Hence it is treated as it is just like a gas molecule. By using these assumptions, it can explain the basic properties of solid, but it fails to explain some of the properties like specific heat of solid, temperature dependence, and electron concentration on the electrical conductivity, because there is a large deviation between experimental as well as the theoretical value. Hence this theory fails. Therefore the next theory arises, that is called as quantum free electron theory. So in 1927, the Sommerfeld and Bose developed this theory, and they have assumed that these electrons are not moving randomly, but it has a definite energy and it will occupy the definite energy levels. By taking these two assumptions, they explained all the basic properties including failures of classical free electron theory, that is specific heat, temperature dependence, and electron concentration on the electrical conductivity. So all these properties are successfully explained, but it again fails to explain some behavior like semiconductor property, because electrical conductivity of semiconductor, again there is a large variation. Hence that theory fails. Next theory arises, that is called as semiconductor theory, or it is also called as zone theory. Here in this theory, the energies are considered as in terms of bands. So one is valence band, another one is conduction band. And the conductivity in semiconductor, it depends upon both electron concentration as well as the hole concentration. So the total conductivity in semiconductor, it depends upon electron contribution as well as the hole contribution. So successfully explained this theory. And the last part of this topic is dielectric material. So dielectric, it is just like an insulating material, but it shows some dipole moment when it is placed in the electric field, and applications of dielectric. So this is the brief things about this module. Next is review of classical free electron theory. In that, free electron concept. Before going to discuss about free electron concept, let us understand what is the valence electron. I hope you are familiar with valence electron. All metal atoms consist of valence electron, and that will be responsible for electrical conduction in the metal. For example, I am going to consider copper atom. So this figure which shows the orbital structure of copper atom. In that, it consists of 29 electrons. The total number of electrons is 29, out of which 28 electrons are filled in a 3 shells like K shell, M shell, and L shell respectively. And remaining one lone electron of an atom will be present in the 4th shell, and that will be loosely bound in the atom. It is called valence electron. Hence, the total negative charge due to the core electrons, including valence electron, which is exactly balances to the positive charge of nucleus, and thus atom will be neutral. So, for example, in case of metal, so it is a collection of large number of atoms. So as we know that each atom which is responsible for one valence electron, hence in case of metal there is a large number, means if n number of atoms are present, means the n number of valence electrons will be present. So these valence electrons are freely moving within the boundaries of solids, and that is called as free electrons, or the free movement of electrons in a solid within the boundaries of solid. It is called as free electron, and that is responsible for electrical conduction. So therefore, the movement of free electron, it is treated as just like a gas molecule. Hence, it will move randomly. So by taking these assumptions, therefore the electrical conductivity of material can be determined, and it is given by sigma, which is equal to n e square tau divided by m, where n is free electron concentration, where E is charge of an electron, m is mass of an electron, and tau is relaxation time. Through this theory successfully explained all the basic properties of material, but it fails to explain some of the physical properties of solid, because there is a large variation in the theoretical as well as the practical value. Hence it is called as failures of classical free electron theory. Now let us discuss one by one. So the first one is temperature dependence of electrical conductivity. So as we know that the conductivity of the material in general, the practical consideration, it is inversely proportional to temperature, or sigma is inversely proportional to temperature. As temperature increases, conductivity decreases. But as per classical free electron theory, it is given by the expression sigma is inversely proportional to square root of temperature. So again there is a mismatch in theoretical as well as the practical values. Hence this classical free electron theory, it is not agreed with the experimental result. Hence it is called as first failure of classical free electron theory. Next is electrical conductivity on electron concentration. So as per the free electron theory concept, the conductivity expression, it is given by sigma, which is equal to n e square tau divided by m, where n is electron concentration. Or it is also predicted that sigma is directly proportional to n. So n means electron concentration. So in this classical free electron theory assumptions, as the electron concentration increases, the sigma conductivity is also increases. But it is not true for in all the cases, because see experimental results of some metals like copper, silver and zinc, which will not shows linearity. So here we cannot say that sigma is directly proportional to n, but it is also dependent on the other two factors such as the relaxation time and electron mass. Hence this prediction of classical free electron theory, sigma is directly proportional to n, does not always holds good. So this is the second failure.